Good afternoon. Welcome to today's Liftoff webinar, and thank you for joining us. My name is Christine Longroy, Vice President of Business Development here at LIFT. LIFT is the National Advanced Materials and Manufacturing Innovation Institute. We're headquartered here in Detroit. We're a public-private partnership and focused on strengthening the defense industrial base. We convene the government, industry, and academia where we advance American manufacturing through technology and talent development with a core mission of ensuring the transition, scale up, and fielding of the advanced materials and processes that support our nation and economy and security. I am pleased to host today's webinar with LIFT member Siemens and honored to have Charlie Hitzen join us. He's the pre-sales solution consultant as he presents Revolutionizing Aerospace and Defense MRO, unleashing the proactive intelligence with the Siemens Intelligence Center X. So during today's presentation, if you do have questions for Charlie, please make sure you put those in the Q&A section, and we will get that at the end of the presentation. So he's responsible on focusing on leveraging the advanced technology, including the AI and digital twins, to accelerate innovation across the entire product cycle. So welcome, Charlie. Thank you for joining us today. So take it away.
Awesome. Thanks, Christine. Appreciate that introduction. Thanks, everyone, for joining the webinar. So like Christine said, Charlie Hitzen here, part of the Aerospace, Defense, and Transportation group at Siemens. And today we're going to be talking about applying AI in the space of aerospace and defense MRO. So a lot of great content to cover, some core examples that I'll show. Just before we get started, in terms of an agenda, my plan is to go through a quick introduction on some of the trends and challenges that we see folks facing when trying to apply these types of new technologies in the space of MRO, and more generally speaking, trying to solve complex data challenges using AI. So I'll introduce that topic and then talk about a framework leveraging context, intelligence, and action to try and solve some of those challenges, some of the ways that Siemens is approaching that. And then at the end, I'm going to share an example, which is this idea of proactive intelligence for aerospace and defense MRO workflows. And it's taking advantage of a new and exciting technology from Siemens called Siemens Intelligence Center X. I'm excited to share that with you at the end. And like Christine said, I'd be happy if you have questions, please put them in the chat and we'll be sure to take them at the end with plenty of time. So to get started, maybe with a quick introduction, the idea is to talk about what industry has been facing from moving from just a digital enterprise to an agentic first enterprise. And I wanted to start by sharing a slide that walks through what that flow and evolution looks like. If you look at the kind of left-hand side, starting with a manual-based enterprise, in the past, nearly the entirety of all of the work that's done across an enterprise is done by a human, right? Somebody doing a task manually. Of course, for the last 15 to 20 years, we've really been focused on the middle bucket there, a digital enterprise. So how do you use advanced software to take those things that a human was doing, maybe paper-based in the past or entirely manually in the past, bring those into an intelligent enterprise system, something like an enterprise system like Teamcenter that can handle product lifecycle management, to then bring that into a digital space. But the real question now is, how do we take those underlying workflows that we've been doing digitally now and bring AI and more specifically agents to help the human with what they're doing? So bring an AI agent to help orchestrate a process with the human in the loop, potentially supervising or helping coordinate action. So the example that you're going to see me walk through today is exactly that, the far right-hand stage where we're truly operating in a fully agentic space. And I'll show you how we're going to get there. The vision might be perfect, right? We want to go to a fully agentic enterprise, but the question is, how do we get there? And what we've seen is that the process and the steps that are required to go from this manual through digital and then into an agentic workflow is not extremely straightforward. In many cases, companies have been out there trying to pilot different projects, specifically AI-driven workflow projects, but many times those pilots fail to reach production. Right? There's a significant amount of those efforts that don't make it into a production sense. So what we're focused on here is not only developing capability to solve a challenge, but also developing capability that's going to scale and enable you to take these types of technologies into production. So before I get into the actual technology, I'll outline some of the hurdles that enterprises face in this agentic space and bringing agents into the workflow that they have. And the first one that I think is maybe the most critical and most important is about context. If you think about AI generally across the entire artificial intelligence space, but even more important when it comes to an agent, being able to ground those types of advanced technologies in your organization's data, your organization's rules, decisions, frameworks, that's all about context for these AI-enabled systems. And in my opinion, it's as equally important to have this foundational context as it is to have an advanced model that can then operate on top of that context. So one core challenge is how do we build the context layer that's going to support these agents and AI-enabled systems? On top of that context, then we want to perform some level of integrated AI and ML type solutions. So, not just being able to develop a custom machine learning model to perform a task, but how do I integrate that to a connected data source and then operationalize it into an application? So integrating AI and ML into the heart of everything we're doing in a workflow. The third element is applications. Obviously, somebody needs to be able to consume the great technology that we have now from AI, and typically these types of technologies get consumed through applications. Many enterprises now are trying to figure out how to take non-AI native applications and turn those into something that can take advantage of the latest and greatest technology. So one of the things that you're going to see me walk through in the example is building applications that are specific to integrating these AI frameworks and agents directly into the heart of what the application does. The fourth element is all about the process. Now we need to think not only about how a human walks through a workflow, but how a human and potentially an agent would work together in a hybrid situation, right? A hybrid human and agentic workflow process. So you really need to think more about how do I orchestrate all of that work to be completed, not only complete the work in silos. And obviously, across the entire ecosystem there, the context, AI, the applications, and the processes, it's required that there's a governance layer. Right? And that's a really challenging problem statement of how do I govern these new types of AI systems that I've never had to govern before? How do I govern new types of workflows where I'm delegating responsibility to not just a human, but also an AI-enabled system? And so if you look at the 5 challenges here, some of these are technology related, some of these are functional and process related, but all of them are things that Siemens is focused on addressing. So you're going to see me walk through, again, an example using our Intelligence Center X solution set today that solves each and every one of these different problems. You'll see me talk about context using our Graph Studio solution, integrating AI and ML using AI Studio and some of the agent building capabilities that we have. You'll see me walk through a Mendix application that's built specifically to build a hybrid and a human workforce where we have a workflow being completed by both of those different elements working together. Again, you'll see that workflow, which orchestrates the process, and then the governance layer, which is orchestrated through the Mendix application as well. So I've said this term Intelligence Center X a couple of times now. I want to give you a sense of where this fits into the entire ecosystem of what Siemens is doing with AI. I know there's a lot on this slide, so just at a high level, I'll cover what you see here. I'll draw your attention to the very bottom box, that AI foundation. The concept here is that in order to enable AI in any tool, right, in any application, there's core foundational elements that are required. A large language model, frameworks like retrieval augmented generation, agentic frameworks, all of those technologies are foundational elements that Siemens has focused on developing and then integrating into our solutions as well. You'll also see a mention there of customer models, customer data. And the idea there is the AI system shouldn't just respond like a generic chat user interface that we're all used to interacting with now, but instead it should be tailored so that it's specific to the things that you're doing, that you're using our solutions for. So that's the foundation layer at the bottom. Obviously, there's a lot of detail there behind the scenes. If you go up one level into these AI native industrial applications, the idea there is whether you're an engineering designer, a mechanical designer working in our CAD solutions, or somebody on the shop floor that's actually executing a manufacturing or a maintenance process, there's AI now embedded in every one of the solutions that you're working with. What that means is you don't have to leave the application in order to take advantage of some of those great AI capabilities. So think about, for example, the mechanical designer that I mentioned. if you put yourself in their shoes, now using our design center solution for mechanical product design, we have a co-pilot that's built directly into the solution, takes advantage of course, the large language models mentioned on the bottom, retrieval augmented generation, and it can help that engineer be more efficient with what they're doing. The top level, level 2, is really what we're focused on in the context of my presentation today, this Intelligence Center X piece. You can see those 5 different pillars that I mentioned on the previous slide where they fit in this agentic enterprise system. And in this context, really this is focused on bringing together information from across your entire enterprise. So of course, you may have some data sources from Siemens, of course, maybe some from your homegrown systems or other systems. All of those come together in this space that allows you to then build agents, use machine learning, use artificial intelligence, and orchestrate these workflows through our Intelligence Center X portfolio. All right, so that's a high-level overview of what this element is. And if we peel back the curtain a little bit to look at Intelligence Center X specifically, that top box, the 3 real elements that we're focused on here are the applications. So the Mendix piece where we're going to build an application, AI Studio, which is where we're building our machine learning models and operationalizing them, and then Graph Studio, which is the context layer as well. You can see how these pieces fit together. The chart on the left-hand side gives you a sense of what this looks like, starting with discrete data that's coming from disparate data sources. You see there represented different documents, databases, maybe a PLM system, an ERP system, an inventory system. All of that feeds together into a knowledge graph created inside of Graph Studio. On top of that, we're going to build a custom machine learning model to perform some tasks, or to essentially identify when a component is going to fail proactively for us. And then we'll use agentic application development on top of that to automate a process that's conducted by both a human and an agent in the mix. So the left-hand side is really talking about the technology, but the right-hand side is also equally important to think about this enterprise trust layer. How do you know what an agent has the authority to do, the authority that it's been bounded to be able to complete? Traceable actions, right? Things that are, as an agent or a human is completing a task, being able to follow those in a workflow and understand exactly what's happened, who signed off on something, and what's been completed. Of course, that's auditable, and it gives you the ability to hold the entire system accountable for the actions that you're going to see as well. So that's the core of the technology element. Now, I'll go maybe quickly through just a little bit more detail on what it is that you're actually going to see from the technology piece before we get into the live demonstration. I've mentioned now these different layers of data that we need, and the first piece of this puzzle, the first piece of this agentic hurdle challenge is bringing together data and context. In this slide, you can see on the bottom these disparate enterprise data sources. Again, that's coming from your company's data, various sources that you need to bring together. Many enterprises have already tried an approach of building this level of an enterprise data platform where you can take data from these different systems, bring them together. Right? In the past, maybe that was a traditional business analytics application, something like dashboarding, right? or other types of business analytics to unify that data. And more recently, the focus is on integrating that data in a way to turn it into something that an AI system or an agent is able to interact with. And so a great way to do that is with an ontology layer. That's what you see in the very middle there. And you can see some examples of the types of data that we're bringing into something like an ontology. In that middle layer, you can see things like my assemblies, right? My manufacturing bill of materials. And typically those are things that would live in a PLM system, but there you can see them represented in context with things that don't live in a PLM system. So maybe like a customer or a supplier, right? Information that comes from a different type of a system. And for those that may not be familiar with that term or that concept of, I've said knowledge graph and ontology now, the idea is to represent the relationships between each one of those different data elements so that an AI system can quickly and easily understand and then interact with that data as well. You'll see that in practice once again in the example. So I've built a context layer. Now what can I do with that? That's the next question. The fourth layer up talks about intelligence. So if I want a custom machine learning model now that is enriched from all of that data across my enterprise, I can use the context layer to build that intelligence layer. And so you see an example of a specialized model, and on the left-hand side, one that's the specialized model that's actually trained on data that's been curated across that knowledge graph. So not just data from a single silo or a single source, but brought together from data across multiple different systems. The top layer, that's my action layer, you're going to see agentic applications here. So humans and agents working together, representing a business process, and of course grounded in that rich context from the context layer as well. So just to give a sense of what each one of these different elements actually look like from the technology perspective, the first piece is this enterprise knowledge graph. I've talked now about bringing the data together into a single system. There's a couple of key ideas that you would think about and be interested in when you start talking about how to actually do that task. Right? And one of those is obviously scale, bringing together data from all of these different large enterprise systems on their own requires the ability not only to manage the ontology and create this graph, but also the ability to scale that graph to hundreds of billions of triples, so that I can then quickly and easily analyze all the data that's in that graph. So there's a significant amount of technical detail there on how to make that happen. But the graph that we bring to this Intelligence Center X portfolio is extremely high performance at scale, which allows you to complete some of these complex analytics challenges. The next piece is intelligence. So I talked about, again, integrating the data from these different data sources so that you can do the traditional tasks that you would do with things like business analytics and machine learning. So this is a deeper representation of what that would actually look like. You can see some examples of specific dashboards that we're able to create, of course, machine learning algorithms that we can create to analyze this data, interact with it, and then deploy that and operationalize it. The interesting part is not only how do we build and do the machine learning and data science tasks that you see in the middle, but then how do you actually use that and deploy it out into the enterprise? And you can see some of the examples of what that looks like on the top. Obviously, in a traditional sense, maybe the application is reporting or business analytics and exploratory analysis of your data, but this also allows you to automate processes, bringing those into workflows, again, that are orchestrated both by humans and agents, and bring it into applications where it can be used inside of a specific data application or data need in an app. So you'll see that in practice too. And then Mendix, right? So this is the piece where we actually talk about turning those concepts, the connected data context, the data science and machine learning, turning that into an application that can be deployed out into the enterprise. And there's numerous elements here that are of interest, but you'll see me talk about the agentic orchestration, so bringing together the hybrid human workforce. And I think it's also important to think about the actual development of the application itself, which we'll talk about. Now, in the example that I'm preparing to show around aerospace and defense MRO, you're going to see that I've leaned heavily forward into agent first, right? Allowing the agent a significant amount of autonomy to go and do tasks for me. But it's important to realize that you should think of matching your AI autonomy to both the level of trust that's required from your industry, but also from your specific requirements and your specific enterprises. So where you fall in this scale will depend on your specific circumstances. On the left-hand side, where you have more human control, right, and less AI autonomy, what you can see is it's really focused on a process. So what you're looking at here is a business process or a workflow inside of an application delivered in Mendix, where a human is really driving and designing a process where an agent can do some specific tasks. In the middle situation here, you see some tasks get completed by a human and some get completed by an agent. So there's a parallel stream of humans and agents working together side by side. And on the far right, where you have full AI autonomy, this is the space now where you're really delegating significant amounts of authority to an agent to go and do the task. Again, the idea is Mendix will support you in whatever you're intending to do in terms of delivering an AI-enabled application, and the level of autonomy that you want to delegate to an AI system is up to you. The way that works in practice is by deploying agents inside of workflows. So the workflow that you see on the right-hand side of the screen, right, you could imagine that this is, you'll see me walk through a specific workflow around part replacement for MRO. But you can see that these tasks can have dependencies, multiple users, agents, humans, and multiple different elements in the mix in order to build a really robust and comprehensive workflow that takes advantage of both of these different elements. And on the screen here, another example where you can see multiple different sub-processes that are happening, some of which getting completed by a human, some of which are getting completed by an agent. Now, what I just walked through is really the workflow piece. So how do I deliver an application that has a workflow involving both humans and agents? But the other piece to be aware of is the actual development of the agent itself. So how do I take this application and develop a custom agent that's going to do a specific task for me? And of course, an agent is made up of multiple different components. Right? You have the large language model itself, a system prompt, tools, various different elements that are required to develop an agent. The ability inside of Mendix to develop, deploy, and govern these agents means that I can be confident about what the agent is that I've deployed, what the capabilities of this agent are, and in fact, I can even test and confirm the behavior of that agent before I go and deploy it into an actual use case. Right? And you're seeing some examples of what that looks like there in the Mendix side. So that's all background that I wanted to share from the side of the Siemens technology that you're going to see in action. Right? That's a solution we call Intelligence Center X, and I think it's really best experienced through exactly that, an experience instead of just slides. So what I'm going to show here is a scenario around proactive intelligence for an MRO use case that takes advantage of all of those foundational elements that I just talked about. So through this point, if you have any questions on the underlying technology, feel free to put those in the chat. But now let's jump over and actually talk about a real use case where we want to apply the technology. All right, so the frame of reference that you should put yourself into the persona of is, imagine that we have a fleet of aircraft. This aircraft is called the Angel Owl, and the Angel Owl is performing a search and rescue mission. And our job is to keep as many of the fleet of our aircraft operational and available as possible. Right? We don't want any to be sitting down in a hangar waiting on repairs to happen. So the challenges that we're seeing in that space of MRO, number one, lack of predictive capabilities that drive reactive response. So how can I predict when an issue is going to happen so that I can plan for it and address it before it's going to happen? Building on that, though, finding an optimal resolution path is not always easy, right? So even if I can predict that there's an issue that's going to occur, how can I then take the information that I have and try and solve that problem, which may require insights from various different systems and various different elements to actually bring an answer forward. And then number three is, okay, so if I've predicted there's an issue, now I've found the optimal resolution path, how can I coordinate the action across various different systems to actually go and maintain that asset? So some of those elements are what we're exactly going to focus on addressing here in this example. So let's start off with an application. And on this homepage here, this is an application developed inside of Mendix, which now everyone on the phone here is an expert on understanding what's going on under the hood here, right? And what you're seeing is data that's being visualized from that knowledge graph. So under the hood in Intelligence Center X, all of the information and context about my fleet of aircraft is contextualized in a knowledge graph. What I see on the screen here is really a view of the entire fleet of the aircraft, right, of aircraft that are operating and what state they're in. So some are currently operational, some are in a maintenance state, some are down, right, for various reasons in a hangar. And really the insight that I'm most focused on is what's the overall fleet readiness at any given time. So our objective is to keep that number as high as possible. Of course, each of those aircraft that are operational are off performing their own missions. And we're adding data now. Not only do we have the traditional data sources that you might think about, but we also have operational data about those aircraft. So if I pull back the curtain and give you a sense of what those data elements actually look like, this is a representation of the knowledge graph we created inside of Intelligence Center X to represent this situation. So on the left-hand side of the screen here in these green, maybe darker green nodes, you can see information that comes from the PLM system. So I have things like my, engineering bill of materials, changes that are occurring, various other aspects about the part and part revisions. On the bottom right here, this is representative of ERP data. So things like my inventory quantities, suppliers with their lead time and quality, right? These are elements that would live in an ERP system. On the top right, I have my MRO or MES system that I'm going to use for MRO in this case. So things like my work orders that need to be performed on these assets. What tools and technicians do I have available? And in the middle, I have operational data. So now that these aircraft are flying, I have things like telemetry and real-time health monitoring that are telling me and streaming information about the aircraft. Right? I have information about the fleet, the operating bases. And so this view that you see here is, again, notional in that it's representative of various different elements that you may have. Of course, you could bring in additional elements that are relevant for you too. Now, this is not going to be featured on the front of the application, so I wanted to show it to you so that you can see kind of what's going on behind the scenes here. On the top right-hand side, now you see this Graph Studio environment, which is the actual technology that we use as part of Intelligence Center X to develop that ontology in the knowledge graph. Okay, so let's put the knowledge graph to use. Now, back in the application, you see a predictive alert that popped up. And so this predictive alert is telling me that there's a component on a drone that's currently operational that has a predicted failure. So using traditional machine learning approaches, we're predicting that there's 10 useful flight hours on a critical component on an operational asset. So now it's up to us to plan for how to solve this problem. Like the drone's going to come back in after its mission, and I need to be able to address this issue, right? Either by repairing, replacing, or choosing not to act on that problem. So the question is, kind of how do we figure this out, right? How do we solve that problem? First of all, the prediction of that alert. Predictive analytics is one key element of this entire AI-enabled MRO workflow. You can see here on the aircraft, the little red alert that's popping up, and just wanted to show you kind of how that actually happens. So as part of Intelligence Center X, we have the capability to both create these types of models to do things like remaining useful life in this case. So here I'm building a machine learning model that looks at various different sensor data inputs that are coming off the airplane, and I'm using those to predict the remaining useful life of a component. Now, building that model is not necessarily the only part that's of interest, but also I mentioned operationalizing that model. So once I've actually done the process, the data science workflow of creating this machine learning model, now I can deploy it into the application. So you're seeing an example of that here, where now I have essentially an endpoint to go and test this model, use it in an application. And like you saw in the Mendix application, that means I can integrate it directly into a workflow and surface that to a user, which is how you saw that predicted alert come up. Again, so we have a drone that's flying with a part that's going to fail in 10 flight hours. So how do we solve that problem? How do we address the challenge? Now, I'm showing first the historical way. So how folks would maybe solve this today. If you think about the type of information you need to try and solve this drone problem, right, or repair this drone, you might start thinking about the types of data that you need. So do I have the right technician when that drone comes back in to land at that operating base? Do I have the person that's actually going to be available to do the work and is certified to do that task? Do I have the tool that's available? Do I have the part? And what I'm showing here is typically the answers to those questions come from multiple systems, right? The inventory maybe comes from an ERP or an inventory system. Here I'm showing my technician schedule and my tooling availability coming from a different system. And in the past, if you wanted a single view that would answer all of those questions for you, this would be a manual process of creating some type of a dashboard or a report that looks at that information. Maybe that's a static snapshot in time, so it's really not up to date with the latest and greatest on all those databases. But regardless, in this case, we've got a problem to solve. So the part is out of stock and it's a long lead item, 6-week lead time. So my drone is flying, it's performing a mission. I know it's going to come back into land, but I know that the part that I need is out of stock and it's going to take me 6 weeks to get it. As a result, right, wearing the hat of this maintenance planner, I just place an order for the part. It's going to return, I'll get the part in 6 weeks. And while I'm waiting on the part, that drone is now going to sit in a hangar and my fleet readiness is going to be impacted as a result. So that's the problem that we're trying to solve, right? Even though we had a predictive model that told me there was a part that was going to fail, because we didn't have a proactive way to try and solve that problem, we didn't really resolve anything, right? In fact, the drone now is just returned from its mission and it waits for the part to arrive and it sits in a down state, impacting my fleet. So what I want to show you now is a better way, right? Obviously, we don't want our drone to be sitting in the hangar, unable to go and operate another mission. So what I'm going to show is a better way or a new path forward, take advantage of this connected context take advantage of that predicted alert and solve this problem in a more proactive approach. So we're back in the same application. We're resetting the scenario now. And in this case, the same predictive alert happens. Drone 456 that's flying has a predicted alert. There's a component that's going to fail in 10 flight hours. But in this case, before a human went to go and look at that static report to answer the questions about the people, the parts, the tools, there's an agent that saw the alert and it starts to try and solve the problem for me. So inside of that Mendix application, I have an agent that's running and it's watching for those alerts. And so when one pops up, what you'll see is this orchestrator agent is starting to try and answer questions for me. It's looking at things like the mission schedule. So how long is that drone actually supposed to be on the ground? Do I even have enough time to replace the part in the first place? Then it says, okay, if I'm going to do a part replacement, I realize I have enough time for that. Let me use some other agents, right, some sub agents to go off and check for parts, check for technician availability, so on and so forth. So very similar to how the human reasons about the problem, the agent thinks in a very similar way. So what you'll see now in the second sequence here is the part agent runs into the same problem that the human ran into. The part is out of stock, and it realizes that it has a long lead time. Now, what it didn't do is just place an order for the part. You'll see it actually says, I found an eligible upgrade that's at a nearby operating base, and I can transfer it to this base, in the estimated maintenance window. So I can get it there in time, and it'll be a faster path to resolution than ordering a part and waiting for 6 weeks. So the question is, how did that happen, right? How did the agent, of course, it can see the alert pop up and start to reason, but how did it find a better path for a solution? So let's take a look at how that happened. If you start from the same realization, we looked at the inventory system and we saw that the part is out of stock. The agent, again, is trying to help us find a faster path to resolution. So it's looking and it's traversing through this ontology, the connected data context. Again, starting in one system, now it's going to look back and try to find a path for a resolution. So you'll notice the first thing it's looking at is what is the engineering configuration for that asset? And the reason that it cares about this is the engineering configuration tells me things like how many flight hours are on those components, right? So if I'm managing my as maintained structure to tell me, how I've maintained that component that's going to fail over time, now I have a sense of how many flight hours does that component have, right? And that can help me potentially find another component that could be replaced for it. In this case, it's also exploring all the way back through the multi-domain engineering bill of materials. So it's looking at things like the engineering structure, this is the software element that it's looking at here. And so it's pulled all of that engineering definition from the PLM system, and it's taking advantage of that so that it can try and, again, find a path to a different resolution instead of just ordering that part. Now, this is an extremely complex task. That engineering bill of materials is a dynamic data structure. Right? As engineers are working on that, there's changes that are occurring, right, that need to be in sync here. There's various different aspects that make understanding that extremely complex. But when you do that with an enterprise knowledge graph, made possible with Intelligence Center X, you can solve these really complex problems. Now, what you're seeing there in the AVI is this agent actually found that there's a defined upgrade path for that exact component. So because it was able to traverse back through the engineering definition, it looked at how that component was defined to be serviced over time. And it found that for this exact configuration of that aircraft, so that exact tail number, there's an upgrade that's eligible. And instead of replacing with the part that's out of stock, I can consider an alternative part and use that part instead. And so think about how complex that is to understand that entire sequence, and that entire workflow was made possible because of that connected context layer. So let's continue through the workflow here. Right? The orchestrator just returns in this application. And the idea is now the orchestrator is gaining additional insight. So because I found a better path forward, my orchestrator can now choose to accept or reject that recommendation. In this case, the orchestrator agent says, yep, I'm gonna go ahead and start to try and resolve this problem for you. And you'll see that not only does it find a better solution, but it acts on it. So it actually takes action to try and solve the problem for me. In that case, the realization of that action is a parts transfer request. So automatically moving a part between bases to get it there before the drone arrives, right? Or as that drone is arriving back from its mission. That entire context layer supported not only finding the path to resolution, but then acting on it to try and solve the problem too. Now, at the end of the day, I mentioned that this workflow involves both humans and agents, right? So you saw some tasks like the identification of the upgrade, the triggering of the parts transfer request, and the sourcing of a technician. Those tasks were handled by agents, and you can see in this workflow tracker the identification that that was actually done by a parts agent and a scheduling agent. Now, some tasks, of course, still have to be done by a human. So, for example, in this case, I'm going to do the actual maintenance task, and as that drone comes back into land, somebody needs to go into the hangar and actually replace that component. But the idea of the solution here is to not only enable agents to do work, but make the human work easier too. In that case, what you're going to see is because I was able to transfer this part, so I identify the upgrade, transfer it, and get it to the correct operating base, I can then also set up a work order with the right context. So it has the correct work scope. I have the right technician that's certified to do the task and available, right, to help me coordinate all that action. I have the right tool that's also available for this work to be done. And the functional meaning there is that when my technician shows up to do this this MRO task, then they need to now repair or replace this component with the upgraded component. They have a work order that describes exactly what process to follow, exactly what parts to use, exactly what tools to use. All that context was brought together because of this context layer and the agent that was operating on top of it. And so what you're seeing on the screen there is an example of what that operator will see when they show up to the shop floor to go and do their task. All the details about the exact sequence of steps as defined in the original service plan. My operator is now doing the work. So they show up, right? They're ready to do their task, and on their iPad or their computer now they have the actual work instruction that describes what to do. They come in, they replace this component with the upgraded component and get that drone back out into service. As you're watching this, you're also seeing from the maintainer's perspective, looking at this dashboard, as work gets completed, I'm tracking the execution status over time too. So this is both resolving the issue for me. It's allowing the agent to take action to help do tasks, moving parts, finding a technician. And it's also giving me as the human insight and the ability to orchestrate the entire process too. Right? So in this case, I have a human that's in the loop, observing and orchestrating. So with this better process as compared to the traditional approach, now we get that drone back into service much faster. The fleet readiness stays high as a result. So you see minimal impact to the fleet readiness. The drone goes back out and it's ready to serve another mission. Compare the way that those two end states happen, right? The historical state being that the drone is waiting for a part, which is frequent in the aerospace and defense MRO situation, right? Where you have a long lead item or a supplier that's no longer available, and you end up with drones or other assets that are not available to serve a mission because they're waiting on a component, when perhaps there was a better solution that just was missed because we were only looking at part of the entire context. So what you saw there is really a workflow talking about how to optimize the sustainment and availability of aircraft using these various different elements. And hopefully the takeaway is it's really not only the AI system itself, the large language model itself, that makes this possible. The knowledge graph under the hood provided all of that semantic context. So I understood the inventory in context of my PLM system with my MES or my MRO system and all of the operational data about the aircraft. On top of that, I had a governed machine learning model. So I was using data that was coming directly from the aircraft itself to build these machine learning models to then surface into the application and tell me when there's going to be a problem. You saw, of course, the agentic application development. So that was a Mendix application embedded directly with an agent. You can both visualize all the data about the entire fleet, but also allow humans and agents to work together in that hybrid human agent workforce to solve these types of complex problems. That also ties directly in with the process orchestration piece, where humans and agents are working together in that workflow. And then, of course, the governance layer, right? So now that I've completed all of that work, I've taken all that information, kept it up to date in the ontology and the knowledge graph. So all of the action is now traceable and auditable of what's been completed inside of that workflow. So again, that was what I was planning on covering. We've got plenty of time for questions. Hopefully it gives you a sense of, we're excited about this new Intelligence Center X solution and a specific example of how to apply that in the space of aerospace and defense MRO. So Christine, hopefully we've got some questions in the chat. I'd be happy to take those. And thanks everyone for the time and attention.
Thank you. Great presentation. Appreciate the detail and the context that you provided. Obviously, this is a great path forward, and I think how you presented it in the detail that you did, the foundational context, all the applications, all the considerations, governance, etc., is super important. So I do appreciate that. So I am going to get started with a couple of the questions that we do have. So how is this agentic approach different from the traditional analytics or rule-based automation in the maintenance, the MRO operations?
So how are agents different than traditional rules-based approaches? So if you think about what you saw with the agent, what I was showing is the ability to delegate some level of that problem-solving process to an agent. In a rules-based approach, you would have some discrete path, right, that tells a system, an intelligence system, how to solve a problem. But with an agent, you're allowing it to go and explore some level of information too. And that doesn't mean that it's entirely unbounded, right? So for example, in the example that I showed where I had a part agent go off and try and source a part for me, find a better option for a part, there's still an expectation that the outcome of that exploration process is a part, right? So there's a bounded level of autonomy that system has to go and choose some other option. If you compare that to what you would do with a rules-based approach, maybe you would have said directly, check the inventory system and then check this other system, if the part's unavailable. But still, the difference is a human would have to put that list together, or that list of rules together, as opposed to allowing the agent some level of autonomy to go and explore and return a better answer faster. So that's how I view the difference.
That makes sense. And you alluded to that earlier, how in this hybrid situation, you have to inform and educate. So that's exactly kind of what you talked about. So thank you for that. What AI models does the AI Studio use, and how does it connect to an overall knowledge graph?
Yeah, great question. So there's numerous different quote unquote AI models that you saw in that entire workflow. So I'll start at the ground level and build up. So if you start from the context layer, the first thing I showed was building traditional machine learning models inside of our solution AI Studio. In AI Studio, you have flexibility to develop machine learning models of really any capacity, any type of modeling that you would do. So that's a core data science question of how to develop those models, and which one you choose really depends on what the use case is and what you're trying to model. Now, there's some nice technology that's also part of AI Studio to help you optimize and analyze. If you're not actually a data scientist, how can you figure out which one of those models suits your use case and your data best? So that's the AI Studio element. On the top layer there, in the Mendix application, you saw another AI model, right, a large language model that was powering that entire agentic workflow. I mentioned when I showed the Mendix agent builder, right, the ability to configure, build, and govern your agents. You also have the flexibility to bring your own model. So depending on what it is that you are trying to do, it's very similar to how different machine learning models apply in different contexts. Different large language models may be suited for a specific application, depending on what you're trying to do at that level too. Some are better at reasoning than others, right? Some have, there's cost difference, right? There's various different aspects of why you would choose one large language model over another. And in the Mendix layer, you have the flexibility to choose that too. So, I think it's a great question, and it's difficult to point to exactly, without looking at a specific situation, what model suits which use case best. But hopefully that gives you a sense that the solution is really flexible for you to do what you need on both the data science machine learning side and also on the generative AI and large language model side.
Thank you. And if there's, additional information at the end, you can contact, reach out. We'll make sure that we make the connection to get specific to answer that. So there's another question. Is there an AI chatbot that you can use to pull data specifically from your loaded data?
Is there an AI chatbot that you can use to pull data from your loaded data? So yes, yes, if you want to use, the Mendix application that I showed was relatively comprehensive, right? I wanted to have a workflow in there. There was obviously the actual data visualization element, the front page that you saw, and various different screens and logic. So that was a relatively comprehensive application. If what you were trying to do is essentially have a front end chat interface to the data that you've loaded into the ontology, you can certainly do that as well, just to be able to ask questions across the entire ontology too. So that's certainly something you can do. In fact, that's part of that application I showed too does have a chat user interface where you can go directly to the knowledge graph to ask questions. So yes.
Excellent. If you change the LLM after setting up the knowledge graph, how does it affect the agentic action?
Okay, so maybe it's worth me mentioning, you should think of these things. The knowledge graph element is the context layer, right? And so you've established your context, and then on top of that is where I was performing both the large language model queries and the agentic action. So if you change the large language model that's powering your agent, you may experience, you could definitely get different results based on the capabilities of the large language model that you get or that you bring into it. So the intent of what we enable with that Mendix agent builder that I showed is the ability to test and configure various versions of those agents. For example, if I had one agent that I liked, it was working perfectly with the model that I had, the tools that I gave it, right, the context that I gave it with the system prompt, everything was working great. And then I want to go and test maybe there's a new model that's released. As obviously we're seeing that very frequently. These new frontier models come out on a rapid pace. So being able to consume those, test the new model, and then before you deploy that into your application, validate that it's performing the way that your previous agent was performing. That's the entire idea of that governance layer and the ability to build those agents inside of the Mendix application. So I think there's a lot of detail there, but hopefully that gives us, hopefully that gives you an understanding of what you were looking to get out of that question.
Thanks. This is what tasks in this workflow are best handled by the agents, the AI agents, versus the human planners, maintainers, operators? Can you break that down a little bit?
Yeah, how do you choose where an agent fits versus a human fits? I think that's a really good question and not one that's easy to answer. So in the workflow that I showed, I had the agent try and help me with some core logistics challenges, finding parts, making sure I had a technician that was certified to do a task and available to do the task. So you can think of those almost like a logistics problem, right? Something that would take a human a significant amount of time to do, checking across various different systems, and something that somebody would describe as being painful for them to go and do themselves. Those types of tasks are great examples of where agents and automation can fit really well. There's still things where human fits too. So, in my example, an easy one to point to is actually doing the maintenance task, right? Somebody was physically on the shop floor or in the hangar going and actually doing that task. Humans also, I think largely in aerospace and defense right now, you're going to continue to see humans being involved in the verification step, somebody being responsible for the eventual output of that system. So while you're able to build an entirely autonomous workflow, I think the human tasks, obviously there's inherent things that we can do well in the physical world, and also things that we can do from the responsibility element too, allowing a human to validate the work that's been done. So in my mind, that's a good way to think about the difference. But of course, that entire workflow that I showed could have been done all by humans or all by theoretically all by agents as well. So like I showed on that scale, the spectrum, where agents and humans fit in a workflow, I think will change over time as well. But hopefully that paints a picture of where it is now.
Appreciate that. I think this is going to be a good one. Because I think there's a lot of people considering this. So what would it take for organization to move from a pilot use case to an enterprise-wide? And maybe there's a step in between, but from a pilot use case to enterprise-wide deployment across fleets or programs?
Yeah, really good question. So in the slide that I showed with the notional knowledge graph, the representation of those various different data sources, I think one of the ways that I think about it is, identify the problem. First step is identify the problem. So what are the things that maybe you've tried to do today using other data approaches and frankly haven't worked? Those are good areas where we could potentially look to try and solve that problem. And I think of those not only in terms of the data problem, but also I describe it as a competency question. So something that if you could ask the question to these various different data systems, what would be those top handful of questions that are relatively difficult to answer, require multiple different data systems, and are something that somebody does today that are high value items. So that's in identifying where to go and start. Then scaling that, as you start to think about, I talked about the technology scale, right? So, allowing the technology itself to scale, but bringing in additional use cases. One of the nice things about this approach in Intelligence Center X is it's modular and composable. So you really don't have to start with the entire ecosystem, right? And every enterprise has so much data, so many different data sources that connecting everything on day one would frankly be a barrier from going from the pilot phase into a production phase. So if you have a handful of really core challenges that you're trying to solve, and you're able to solve those by integrating the data sets that are required, and then as you want to expand that, maturing both the data side, the context layer, and then also the agents in the application side, you can bring in more detail, more capability over time. So that's, I guess, one of the ways that I think about the scale. It's starting small with a really valuable, challenging use case, and then building with additional data, agents, and application areas as you need over time.
Excellent. I think that is kind of wrapping up our question. Let's just see. I think one more just came in. Can an AI agent scale to handle a massive multimodal aircraft data? Is the processing speed slow when agents handle that much information?
Yeah, so this is exactly what this solution is aimed at, is the really large scale application, right? So the answer is yes, short answer is yes, but the more nuanced answer is the way that you enable an agent to handle that scale is not simply by dumping data into something like a data lake to go and allow that agent to try and parse it. If you think about on a large aircraft program, all of the different enterprise data sources that are relevant to try and solve problems that come up with an aircraft, dumping all of that data into a cloud data lake is just not an approach that will allow an agent to operate at scale and at high performance. Instead, the approach that I showed here using that context layer at the foundational level allows the agent to have almost an identified path, so that instead of trying to understand all of the data, it can look at the relationships and find the right ways to go and explore the data that it needs. So short answer is yes. Can it happen? Yes, of course. And the way that it's enabled is really through technology like what I showed here today with Intelligence Center X.
Well, that was a great answer. Thank you for that. Obviously, the intelligent foundation of this technology solution is really relevant and important. The predictive insights, obviously the coordinated action. So I appreciate your presentation today, Charlie. It was phenomenal. Thank you all to those that attended and all the very good questions that came through. We do appreciate this. We do appreciate Siemens as a member here at LIFT. I'd like everybody to mark their calendar for our next Liftoff webinar, which is going to be August 29th, featuring Questech Innovations on accelerating defense manufacturing through ICMD-driven materials innovation. So thank you, Charlie, for a phenomenal presentation. Appreciate it. Everybody have a great rest of the day and week and weekend. Bye-bye.
Thanks, Christine. Thanks, everyone. Bye.